Okay, ladies and gentlemen, let's talk some basic ratios. So anytime we start talking about ratios, ratios compare two like things. Two like things. So for example, let's say I have a class of 24 students, and I have, let's say, 14 boys, and therefore I would have 10 girls. I would say that the ratio of boys to girls would be 14 to 10. Now, that ratio is true. I could make that ratio smaller by reducing, divide the top by 2, divide the bottom by 2, and come up with 7 over 5. So my ratio would be 7 over 5. So if I had, say, 20 girls at a ratio of 7 to 5, since 20 times 4 is 5 times 4 is 20, I'm going to multiply 7 times 4, and that would make there be 28 boys. So it doesn't matter whether it's 14 over 10, 7 over 5, 28 over 20, the ratio stays exactly the same. The kicker is the mix doesn't really change. So with that, we have this idea of ratio. Now let's say there are 14 boys in my class, and there are, I don't know, 17 boys in Miss Cosley's class. You say, well, okay, that's a ratio because that's boys to boys. And you say up here it says boys to girls. That doesn't make any sense because I know from health class that boys and girls are different. Well, yes and no. Boys and girls are only different as two different types of students. So in that sense, they very much are the same. Now, what we would compare that again, where those are ratios, let's talk about something else called a rate. A rate would be like $3.25 per 1 gallon. Now, unlike boys, I have 14 boys to 17 boys, or 14 boys to 10 girls. Those are people to people, people to people. A rate is not a ratio because in this particular case, we're talking about gas to money. So if we're talking gas to money, then we have unlike things. One is a unit of money, one is a unit of volume. So we would need to be careful about putting those two together. That would be called a rate. Or for example, if I had $1.25 for a pound of hamburger, that's different. Dollars to pounds, dollars to gallons. Those are different things. Boys to girls, same thing. 14 boys to 7 boys, that's the same thing. Now, if we had something like wins to losses, that would be a ratio because it's games to games. If we were starting to talk about how much money a certain player makes in one league compared to how much a certain player makes in another league, that also is a ratio. Okay, but if we're talking the amount paid for a car compared to the amount paid for a baseball player, probably not a good ratio because those things are very, very different, even though they'd both be money. So, among our things we need to be careful of is a ratio compares two like things. And we need to be able to stack those up. We need to be able to reduce them. We also could make them bigger if we needed to figure out how many people are needed in an entire group. One thing we need to make sure we can do with rates and ratios is we need to be able to compare them. We all know that $3.28 per gallon is more expensive than $2.99 per gallon because that number is obviously bigger per gallon. But the question becomes, what happens if I have $25 for 6 gallons and I have $34 for 8 gallons. Well, which one is more expensive? One of the easiest ways to compare these two is to find a decimal. So, if we grab our calculator, we say 25 divide by 6, that's 4.166. You have 34 divide by 8. 4.25. Now as decimals, they're easy to see which one is bigger and which one isn't. That works for rates, but it also works for ratios. 14 boys to 17 boys. Does that match up, or is it greater than or less than 14 boys to 10 girls? Well, again, we're going to do some division. In this case, 1.4. And over here, we would say 14 divided by 17. 14 divided by 17. The answer is 0.82. Well, which one's bigger? 0.82 or 1.4? The obvious answer is 1.4 is definitely bigger. So that's how you compare rates, that's how you compare ratios.